Dear students, very good morning. Yes, we are discussing about changing the order of integration and its evaluation. So we are going to discuss very important problem today. The problem today we are going to discuss is very important problem. That is, we are having double integral. The first integral varying from 0 to a, that is we are having constant limits, and the second integral is varying from integral a minus root of a square minus y square, and the outer limits, that is the upper limit, is up to a plus root of a square minus y square. Okay, a square minus y square, and these limits are having no functions. Instead we are having only one as the function for the operators dx and dy. So we want to evaluate this double integral after changing the order of integration. Because it is not mean that it's not possible to solve as it is, but the challenge here is to change the order of integration. Okay, and we want to evaluate it. That is the question in our engineering mathematics. So what does the limit express? That is the first thing we want to find. What is the meaning of the limits? The limits are x, okay, x equal to a, okay, x equal to a minus root of a square minus y square, and x equal to a plus root of a square minus y square, and we are having y equal to 0 and y equal to a. So these are the four things we are having. So what does these limits express? So I am taking square on both sides. I get x square equal to a minus okay, so before taking the square on both sides, first let me bring that a to the left hand side. Okay, then it will be more comfortable. So x minus a equal to minus root of a square minus y square. Here it is also x minus a equal to root of a square minus y square. Okay, so after squaring on both sides, we can write it as x minus a the whole square equal to equal to a square minus y square. Here also we are having x minus a the whole square equal to a square minus y square, and both these equations are equal. So this implies this and this implies this. Okay, so we can write it as a single equation, x minus a the whole square, x minus a the whole square, plus this y can be written as y minus 0 the whole square equal to a square So this equation represents a circle. So we are going to draw a circle. Okay. So this is that circle. Okay. See, first before that let me fix the limits. This point is, what does this point mean? This point is 0, 0. This point is 0, 0, and I want the radius to be a. Okay, radius to be a and center to be a, 0. Center to be a, 0. Okay, if I am taking this as a, this as a, and this point will become a, 0. Okay, so now I shall draw a circle with center at a, 0. Okay, with center at a, 0. Okay, see, if this is the center, if this is the center point a, 0, this distance is radius and this is equal to a. This radius is also a. So the total distance is, the point here is it is 2a, 0. The point here is 2a, 0. Okay, the point here is 0, 0. The point here is a, 0. the point here is see what does this point mean. The point here, this equation represents y equal to a, and this point represents y equal to minus a, and this line is y equal to 0, and this line is x equal to 0. Okay, so we have enclosed the circle with the box on the outside, okay. So it will not be a rectangle, it will be a square. Because we cannot enclose the circle touching all the 4 points of the circle, okay, all the 4 points of the circle within a rectangle, okay. If it touches the 4 points means then it will be square. If it touches the 2 points means it will be rectangle. If it touches 3 points means if it is triangle. That is the main relationship between circle and square, or circle and rectangle, and circle and triangle, okay. So here we have enclosed a complete figure, okay. So the equation of circle is x minus a the whole square plus y minus 0 the whole square equal to a square. This is equation of circle. But here we can see that x is the inner integral operator. If it is differential equation, we call it as differential operator, okay. So d of means differential operator, integral dx means it is integral operator, okay. See here, I want to draw the internal strips parallel to x-axis, okay, parallel to x-axis, because the inner integral varying from the limits of x. What are limits of x? The limits of x should be in y. Then only it is in correct form. So here this is the strip, okay, So before that we want to clarify what is the region of integration. So for that, let me show you graphically, okay. X is varying from a minus root of a square minus y square. So this equation is root of see, if a minus means left, since a is the center, a minus means this curve. This curve is called, the limit is called a minus root of a square minus y square, since a is the center, okay. since A is the center, this is A minus, and this will be A plus root of A square minus Y square. Okay, so the X limit lies between these two, and the Y limit lies between, this is Y equal to 0, and Y limit lies between these two. So our region of integration is lying between, see, on x side we are having this as the lower limit. Okay, this as the lower limit. Okay, this as the lower limit, and this is the upper limit. See, this is the lower limit and this is the upper limit. Okay, and for Y the lower limit is this, okay, because Y equal to 0 is lower limit, and the upper limit is this, Y equal to A. So the region of integration is existing within this area, and for this area we have to draw the internal strips, that is horizontal to x axis, okay, horizontal to x axis. Okay, horizontal to x axis. Now we have taken this limit x varying from a minus root of x minus y square to a plus root of x minus y square, and y varying from 0 to a. Okay, this is what the given integral equation mean. Okay, if suppose I want to change the order, then what can I do? I have to change the internal strips also. So for that I am taking another equation, another diagram. See, nothing will change, only the strips will change and the limits will change, the diagram will not change. So here the point is a comma 0, the point here is 0 comma 0, and we want to draw the circle with center A and radius A, okay, with center A and radius A. Okay, so in this equation we are having the points. This point will be 2a comma 0, 2a comma 0, center is a comma 0. Okay, center is a comma 0. This is origin 0 comma 0. Okay, and this point, okay, this point is y equal to a, because this point is what, see, this point is actually a 0 comma a, so the equation on this line is y equal to a, and this point is 2a comma 0, this point is, and the equation for this is x equal to 2a. Okay, this point is, okay, this point is also having the same radius but in negative axis of y, so we are writing this y equal to minus a. This is y equal to 0. Okay, and this is x, this line is x equal to 0, this line is x equal to 0. Okay, so we have drawn the same circle, but one thing I have to mention, I have mentioned the two left and right limits of this circle, but there is a top and bottom limits also. There is a top and bottom limits also. If I take x, see, from this equation, if I want to take x, I am having a minus root of a square minus y square. If I want to find y, what will be y? Y will be, see, y square equal to a square minus x square, x minus a square minus x minus a whole square. Okay, and so y equal to root of c plus or minus a square minus x minus a the whole square, x minus a the whole square. Okay, so this is nothing but y equal to positive, so root of a square minus x minus a the whole square. Okay, and this is minus root of a square minus x minus a the whole square. Okay, so we are going to consider the same thing. See, for horizontal strips, if taken, means the internal limit should be variables in y. If our region of integration is same, our region of integration should be same. The region of integration should not be altered. Our region of integration is this. Okay, this is the region of integration and this should not be changed. Okay, but what have to be changed? We have to change the horizontal strips into vertical strips. The horizontal strips into vertical strips, because we are changing the order of integration, so that internal operator dx will change to dy. Okay, so here since we are taking internal limit as y, the y should be the variable. Internal limit y should be the variable, so that y could be taken as what is the equation of y? The equation of y is written here. See, this equation is written here. What is written? Root of a square minus x minus a the whole square. X minus a the whole square. Okay, this is our upper limit of y. Okay, and the lower limit of y is as it is, y equal to 0. Now the internal limit, that is for x, will change. Here x limits are in variables of y, but here x limits are not a variable limits. Here we are having x equal to 0 to 2a, x equal to 0 to 2a. So the given equation, what is given? See, this equation is completely changed to y equal to internal limit. Internal limit is changing from y equal to 0 to root of a square minus x minus a whole square, and x limits are changing from x equal to 0 to x equal to 2a. Why? Because the external limit should be the constants, whereas internal limit should be variables. Okay, that is the reason we are not taking x equal to 0 and x equal to 2a. Here we are taking x equal to a minus root of a square minus y square, x equal to a plus root of a square minus y square as the lower and upper limits respectively, whereas here the x limits are constants because x becomes the external limits. Okay, and here y become integral operator, so we are taking these variables as the limits of y. So the limits of y should be in variables of x, so we are taking y equal to 0 to not y equal to a. It is not y equal to a, it is root of a square minus x square. It is, since it is integral limit, it should be the variable of x. Okay, So we are taking like that. So the given question, the given integral equation. So what is the given integral equation? The given integral equation, double integral, okay, double integral 0 to a, and after that a minus root of a square minus y square to a plus root of a square minus y square, a square minus y square dx dy is now changed as double integral. The external limits are same. See, first of all I shall write here the operators dy and dx. So the external limits should be the limits depending on x, and it should be in the variables of y. So it is we are having so the in external limits is varying from 0 to 2a. X is varying from 0 to 2a. The internal limits y should be the limits on x, depending on y should be limits on the variables x. So y is varying from 0 to root of a square minus, because this is 0 to root of a square minus x minus a the whole square, x minus a the whole square. Okay, a square minus x minus a the whole square. See, if I am considering entire region, then this will be taken. If I consider entire region, the lower limit of y will be taken as minus root of a square minus x minus a the whole square. Okay, but for me it is not necessary. The limits are beginning from 0 to this, and for y, and limits are beginning from 0 to 2a for x. Okay, now I hope you understand. I hope you will understand how the given function is transformed. Okay, how the given function is transformed. Okay, you have to be very clear about fixing the region of integration and fixing the strips, and also how to change the limits according to that. Okay, see, now instead of solving the integration with both variable limits, we are going to solve with only one variable limit. So what will be easy? Definitely this will be easy than this. So we are going to solve this. Okay, we are going to solve this. Okay, because integration double integration, there is a property that integral, double integral f of x comma y dx dy equal to double integral f of x comma y dy dx. If I am taking a, b and c, d means the limits will also change, c, d and a, b. See, I am telling this for an example. Since they are constant limits, they will be equal. But for variable limits, we will have some other expression for a and b and some other expression for c and d. So on that case, limits will not be equal. On that case, the limits will not be equal. But what will be equal? If the limits are correct, okay, if the limits, this is for constant limits. Okay, if the limits are correct, then for any variable limits, for any limits, the order changed integration will be correct. Order changed integration will be equal. That is what the change of integration mean. That is the purpose we are using the change of integration. So now we are integrating this integral 0 to 2a, this is y. Okay, integrating dy we will get y. So y will give 0 to root of a square minus x minus a the whole square, a minus x minus a the whole square into dx, and this will be integral 0 to 2a root of a square minus x minus a the whole square dx. Okay. So to evaluate this integral, we know the formula. There is a formula, integral 0 to a in anything. Okay, integral a to b or whatever it is. Simply I can write integral. We are having some limits here. The integral root of a square minus x square dx equal to x by 2 root of a square minus x square plus a square by 2 sine inverse of x divided by a. So instead of x we are having x minus a. So this will be we are having x minus a by 2, x minus a, okay, x minus a by 2 x minus a by 2 root of root of a is a itself, a square minus x minus a the whole square, x by 2 root of a square minus x square is a square minus x minus a whole square plus a square by 2, that is a square by 2 itself, a square by 2 sine inverse of instead of x we are having x minus a divided by a, okay, x minus a divided by a. So that is the limits are 2a to 0. Okay, so if I substitute 2a, what will become 0? If I substitute 2a, this term will become 0, because 2a, if I substitute x equal to 2a, I have to substitute 2a for all the x, but it is not necessary to substitute 2a in all the limits of x. Just we are verifying where it will become 0. Okay, where it will become 0. So if I put 2a, here, it will become 2a minus a, that is a square. So a square minus a square is 0, root of 0 is also 0, so this 0 into this term will become 0. So that the first term is 0 plus, if I put 2a here, it will become 2a minus a. Okay, 2a minus a is a by a is 1, so here we are having a square by 2 sine inverse of 1. Sine inverse of 1 is pi by 2, sine inverse of 1 is pi divided by 2. Okay, so this is our upper limit, minus we have to substitute the lower limit. So if I put 0, what will become 0? We have to check. See, if I put x equal 0 here, it will become minus a whole square, that is a square. So a square minus a square is 0, the root of 0 is 0, so 0 into this term will become 0. So first term is 0 here, plus a square by 2 of, so it is, if I put 0 here, we will have 0. Okay, we will have it x equal to 0. So 0 minus a is sine inverse of minus a, so that minus will come outside, so it will become minus of a square divided by 2 into pi by 2 into pi divided by 2. Okay, so this is nothing but pi a square by 4 pi a square by 4 plus again this minus will become plus again pi a square divided by 4 and that is equal to 2 pi a square 2 pi a square by 4. The final result is pi into a square divided by 2, pi a square divided by 2. Okay, I hope this video will be useful in learning how to solve the problem related to double integral in the limits with the limits having in circles. The limits having in circles. For limits of circles, we have shown how to solve the problem. Okay, we have shown how to solve the problem. See. Okay, so this is the way how we want to find the limits. Okay, thank you all for watching this video. Thank you all once again.